September 29, 1962, a day that changed Canada's place in space. With the launch of Alouette 1, Canada became the first nation other than the US or the Soviet Union to design, build and launch its own satellite. Today, that pioneering mission still orbits Earth, and its legacy continues to teach us about space, science and human curiosity. Welcome to the story of Alouette 1. Let's dive in. To understand Alouette, we must first set the stage. The late 1950s and early 1960s were dominated by the space race. The Soviet Union had launched Sputnik, the United States countered with Explorer, and both superpowers raced ahead in satellite technology and strategic prestige. In this environment, Canada faced a challenge: how to contribute meaningfully to space science without being overshadowed. The US had invited international partners to propose experiments for satellites. Canada's scientists answered with a bold idea. What if Canada could build its own satellite to study the ionosphere, the upper layer of the atmosphere that reflects radio waves and affects global communications? No country had yet built a satellite outside those two superpowers. Alouette would change that. The engineering of Alouette was ambitious, especially for the era. Canada's Defence Research Telecommunications Establishment, DRTE, led the effort, collaborating with contractors and international partners. Canadian Space Agency, +2 canrev.ie.ca +2 key features. Alouette's mass was about 145 kilograms. Wikipedia +1, it carried several scientific instruments. A sweep-frequency sounder to probe the ionosphere by sending radio pulses and measuring reflections. A VLF, very low-frequency receiver, an energetic particle detector, cosmic radio noise measurements. Skyrocket Space +1, a signature design, long deployable STEM antennas, strips rolled up like tape measures which would unroll into long wires once in space. Wikipedia +1, it used solar cells and batteries for power, and transistors, still fairly new at the time, for electronics. Ingenium, +2 Canadian Space Agency, +2. Because many parts of space engineering were novel or unexplored, the team emphasized reliability, redundancy, and conservative design margins. As it turned out, that was key to Alouette's survival. On September 29, 1962, at 6:05 UTC, a Thor Agena rocket from Vandenberg Air Force Base, California, carried Alouette into orbit. Wikipedia +2 Canadian Space Agency, +2. The orbit was nearly circular, at about 1,000 kilometers altitude, with an inclination of 80.5 degrees. Wikipedia +2 Skyrocket Space, +2 once in orbit, the satellite spin-stabilized itself, about 1.4 rotations per minute, to maintain orientation. Skyrocket Space +1. The antennas were deployed, and data collection began. However, data could only be transmitted when Alouette passed over one of the ground tracking stations. There was no onboard tape recorder to store data for later. Skyrocket Space +2 Canadian Space Agency +2. The plan was for a one-year mission, but Canada's engineers had gambled on durability. Almost immediately, the engineers faced uncertainties. For example, after about 500 days, the spin rate slowed quicker than anticipated, from approximately 1.4 revolutions per minute to approximately 0.6 revolutions per minute, and spin stabilization became unreliable. Skyrocket Space +2 Wikipedia +2, without reliable spin, orientation determination was limited. The satellite relied on a single magnetometer and temperature sensors to estimate its attitude, with errors up to +10 degrees. Skyrocket Space +2 Wikipedia +2. Some doubted whether Alouette would even operate at all, especially in light of the Starfish Prime high-altitude nuclear test, July 1962. Which generated radiation bursts that disrupted satellites then in orbit. Canadian Space Agency +1. Yet despite all that, Alouette kept working. Designers had built in extra tolerances. For instance, the transmitter's power was overbuilt by a large margin to accommodate degradation. Canadian Space Agency. Over its lifetime, Alouette transmitted millions of ionospheric measurements, far outlasting expectations. Alouette's mission officially ended on September 30, 1972, giving it an operational life of 10 years. Wikipedia, +2, canrev.ie.ta, +2. It outperformed its one-year design life by an order of magnitude. Canadian Space Agency, +1. Why was it so successful? Conservative engineering margins and redundant design, rigorous quality control on electronic components, overbuilding performance capacities to accommodate degradation over time. Canadian Space Agency. After retirement, the satellite remained in orbit. It continues silently circling the Earth. Wikipedia, +1, but Alouette's legacy goes beyond its orbit. Its success inspired the ISIS, International Satellites for Ionospheric Studies program, a US-Canada partnership for further ionospheric research. Canadian Space Agency, +2. Canadian Space Agency, +2. In later years, the mission data, stored on film and tapes, was nearly lost, but in the 1990s and 2000s, massive efforts digitized and rescued these archives, making them accessible for modern analysis. Canadian Space Agency. The knowledge from Alouette improved our understanding of radio communications, space weather, satellite communications, and contributed to Canada's reputation in the global space community. Ingenium, +2, Canada.ca, +2. In 2007, the Canadian government designated the Alouette program a National Historic Event, pc.gc.ca, +2, Canada.ca, +2. Alouette remains a symbol. With ambition, thoughtfulness, and resilience, even a small nation can make a lasting mark among giants. Why does Alouette still matter? Here are a few lessons for today's era of space exploration. Engineering for longevity matters. In a field where many missions fail early, the decision to over-design pays off. International collaboration is key. The US provided launch facilities and ground support. Canada provided the science and engineering, value of historical data. The digitized Alouette data gives scientists a window into Earth's ionosphere in the 1960s. Something few modern missions can replicate. Inspiration for smaller players. Alouette is proof that you don't need to be a superpower to contribute in space. Today, many emerging space nations and private companies follow that spirit. Scientific curiosity endures. What began as radio wave experiments now feeds into contemporary studies of space weather, satellite communications, GPS reliability, and more. So next time you stream over satellite, navigate with GPS, or track solar storms, remember that some of the groundwork was laid decades ago by projects like Alouette, quietly orbiting above us. From humble beginnings to a decade of scientific discovery, Alouette 1 stands as a shining example of what vision, collaboration, and perseverance can achieve. Its signals are silent now, but its echoes live on in every satellite, every radio wave, every pulse of data traversing the sky. If you enjoyed this journey through space history, smash that like button, subscribe, and hit the bell icon so you don't miss upcoming stories about space, science, and exploration. Drop a comment below. What other hidden missions should we cover next? Thanks for watching. We'll see you on the next orbit.